We now go to our experiment number 3, no? And this is part of our performance tasks number 5. No? Performance tasks number 5 is our second performance task for the second quarter. And this one, no, what we will be doing here is that we are going to submit a written lab report, no, similar to our first two. No? So we call it basically as experiment number 3. No? So every group again, no, will probably make a submission, no? And however, no, every member also will upload in their final output a copy of their group's work. No? So you will be graded here individually again as part of your group. No? So involvement of everyone is very, very important. Now again, experiment number 3 is called as the center of gravity, or we shorten it by the symbol CG. No? And the goal or objective of our activity is to find that coordinate. No? So coordinate would refer to a Cartesian coordinate of x and y value. So that is the coordinate of an unsymmetrical figure, or I usually call it as composite figure. So our unsymmetrical figure may consist of squares, rectangles in combination. So if we'll try to cut it out into those regularly shaped figures of squares and rectangles, then you will see that it's a combination of all that figure. Now, the materials that you are going to need, so first of all, you have to create or make one composite figure, and I will teach you how to do that. Next, you have to prepare a string or yarn and a push pin. So you will need some push pins. So those are our push pins. And a small metal object, or if you have a slotted weight. A slotted weight is basically a material that is found in the lab. And of course, following that one will now be our procedure. But beginning with our procedure, so these are the materials that we are to gather. So you could have a string there, a string that is enough for you to be able to create a plumbline. And we are going to describe what is a plumbline, of course. So you need to have also a push pin, and this is what I call as a slotted weight. But if you don't have this at home, you can just find any small metal where you can tie it with a string and be able to create what we call a plumbline. Now, again, I will illustrate to you a plumbline later, how to make one. Now, this is our composite figure, and in each group, you have to create your own. You cannot use this one. So you have to create your own. I'll teach you how to create one. But you cannot use this figure here. So this is just an example. Now here's a picture of a plumbline. Again, a plumbline will need a string or yarn. And at the tip of that yarn is a heavy metal. And what's the purpose of that? So when you suspend the metal that is at the tip of the string and hold the other end with your hand or with your fingers, then you'll create this line that is exactly perpendicular to the ground. So this line is actually believed to be a straight line that is always our basis to know whether our wall or our mga haligi, isang balay natin, if it is straight or not. So if it's leaning on one direction, or if it's vertically position based from the ground. So that's the purpose of a plumb line. We'll be able to trace a line here created by this string. Again, you just simply held that and you don't let it move. So by actions of gravity, you'll be able to create this plumb line. So this is the plumb line, basically, this one. So that's the one that you will need. So maybe you'll look for a metal where it's heavy enough for you to create this line. But it's not really that heavy, because you will not really need a very, very heavy metal there. Just some metal to be able to trace this line. Now, let's start with the creation of your composite figure or your unsymmetrical figure. So you will get maybe a cardboard a piece of cartoon, no? Maybe a part or a portion of a box like this, no? So any box like that one, no? So you can cut out a square box, no? Or square part of this box, no? Or cardboard. So just use any discarded boxes, no, that you don't need in your house, no? So that is an 8 by 8 square, guys, no? Because each of these smaller squares is 2 centimeter by 2 centimeter, no? So if this is 2 centimeter all throughout, so that's a total of 8, no? Downward is also 4 small squares. So if each small square is 2 centimeter by 2, so this is also an 8 centimeter, no, na figure, no? So this is basically an 8 by 8, no, centimeter, no, na flat square cardboard, no? Now out of that flat squared cardboard, no, you can build your own, no? You can cut, no, from its edges, no? So you can remove this portion here over this portion and be able to end up with a figure something like that, no? Now again, no, this is just a suggestion, and for your group, you have to make your own, no? You have to make your own, no? So you can cut again, no, sections of that cardboard, no, and be able to end up, no, with a different figure like this one, no? Similar to this one, no? But you have to start with that 8 by 8 square, no? So that's now our end up, no, composite figure. So this composite figure is not a square anymore, no? It's not a rectangle either, no, but it's a combination of all those figures, no? Now again, no, our initial position here, and if you recall your method of finding the center of gravity, no, for our theoretical process, no, so we have a formula there, no, which is x bar is equals to a1, no, times x1 plus a2 x2 plus a3 x3, and again, no, it depends on how many areas you will end up there, no? Now, you see that the center of gravity is a fixed location. So if you will be rotating this figure time and again, no, we will end up with a different coordinate, no? So that now we will end up with a similar value, no, for all of us. Then we will agree, no, that if this figure will be positioned in this way, no, none of us will rotate it, no, so that now we will have a uniform answer, no? So let's just position it in this manner, no, eventually later. So this is our final position of this composite figure, no? And this is how we will locate later its center of gravity, no? Now we will divide our process of finding the center of gravity, no? 1 by experimental method and 2 by theoretical method, no? So the theoretical method will use the x and y axis, no, and all that succeeding, no, methods that we have, no. Now for our experimental method, let's begin with our experimental method. How do we locate, no, our, no, center of gravity of the figure, no, using the experimental method, no? Now again, no, we will get our push pin, no. So getting our push pin, we are going to pin it, no, on one corner, no. So there are actually several corners for this figure, no. So this is a corner here, or this one, no? But let's just say we select this portion here as a corner where we pin the figure. And now once we pin it there, we are going to make it rotate about that point, no? The point where we pin the figure. So by moving the figure there, no, again and again, no, maybe you can even turn it all the way, no, until it can freely rotate, no? So that's very, very important, no? So move it around about that push pin, no, and see to it that it is now free to rotate, no? Once it's free to rotate, then you can now, no, add your plumb line, no? So the figure, for example, is now freely rotating about that pin, no? Then now, no, we can add, no, our, no. So since it's now freely rotating in that portion, no, we can now add our plumb line, no? So let's add our string and then the weight, no, in the other end of the string, no? So you'll notice if you'll just let it stay where it is, no, that a line is traced, no? So this is now the string, no? However, no, we need to get pencil, no? A ruler and a pencil to trace this line. No? It's important that after you know where it is, no, you have to trace a line, no, using a pencil. No? Because when you remove this, no, then we will not know, no, where that plumb line passes. No? So we are going to trace a line from this end, no, or that corner of the pin, no, up to where, no, the plumb line traces. No? So draw a line across here. No? And when you have drawn the line using your ruler and pencil, then you can now remove the pin, remove the plumb line, and transfer now the pin to a different corner again. No? So we will apply the same technique, but this time, maybe position it here, no? Or maybe over there, no? And choose a different corner. No? So we will apply or do the same thing. No? So we remove, no? We remove the pin, and now, no? Transfer the pin on a different corner. No? So this one now is a different corner. I think we were right here. No? So we move back. No? So we transfer on a different corner. And then again, no? Do the same thing. No? We will make it rotate first. No? We rotate it several times until it is freely moving around the pin and attach the plumb line again. No? So attach the plumb line. Again, the plumb line consists of the string and the slotted weights. No? Use a ruler and a pencil to trace the line after you see, no, where the plumb line is. And now, no, after you trace the second line, no, and I believe now you have now an intersection there. No? You will now remove your pin and your plumb line and position it back. No? So you have now your traces of line there. Position the figure now, no, in our Cartesian plane. No? So where do we usually position that? In the first quadrant. No? So now the lines that we've drawn earlier, no, the one that we traced using the plumb line, using our pencil and ruler, no, is probably, no, this blue lines over here. No? And we see that there's an intersection point now. No? Now that intersection point, now using our experimental method, traces now our center of gravity. No? So you could now project this line downward, no, and get an x value. You can likewise project that to the left, no, and get a y value. No? So x and y value will now be recorded, no, as part of your CG, no, here below. No? So you'll have your x, comma, y value. No? So maybe you can divide this equally, no, using your, no, your trace line here. So maybe this is 2, 4, 6, no, 8, no, and then this one is also 2, 4, 6, 8, 9, so on. And again, no, you can now estimate now where is the location of your CG. No? Okay, so using that trace line. No? So our CG again is an ordered pair. So this is our experimental process. No? Now we are going to compare our method, no, using the theoretical method. No? So after knowing the CG using experimental method, the theoretical method now will still now make use of that same figure and positioning that same figure now in the same way, you know, like we did in the experimental method when we put it in our Cartesian plane. No? Now our theoretical method requires us to split this into regularly shaped figures by drawing lines. No? Okay, so you remember that. No? So we have that in our lecture. No? And then we call the sections now. No? So maybe this is first figure here. No? So we call it area 1. Area 2 is this one, no? Below. No? This is our area 3, area 4, and then we have area 5. No? Again, remember that the rule for dividing the figure there, no, should follow, no, in such a way that you should end up, no, with the least number of figures. No? So again, our figures are like this. No? So this is area 1. This is our area 2. No? So that's a square there. This is our area 3. This is number 4. No? And this is our area 5. No? So that's that. We really figure that out in such that in that manner. No? So maybe now you need to know the dimensions of that area, no? And you need to know their coordinates as well. Now, once we know the values or the areas that we have, then we draw our lines there, no, our diagonals. And once we draw our diagonal, then we get their corresponding x and y values, no, for our area 1, area 2, area 3, 4, and 5. And just like what we did, no, in our lecture, no, for unsymmetrical figure, no. Okay, so again, no, our figure here now will make use of this table, no. So since we have there 5 figures, then maybe we need to add, no, 2 more columns here, no. So we have 1, 2, 3, 4, and 5. No? So this is merely an illustration, no, that we only end up with 3 figures. But if you have more, if you have 4 or 5 or 6, no, then you need to add more columns there. No? So these are our figures, then their corresponding x and y values. No? So their corresponding x and y values will depend, no, on where is this intersection of the diagonal falls. No? So again, x1 will be the line that is traced going downward, not to the x-axis, and the line extending on the y sub 1 value. No? So x1, y1, no, will be the intersection of these lines. No? Okay, so again, these are our diagonals, no, and you need those values, no, for your table over here. No? So you need to plot now the pairs of x sub 1 and y sub 1, including the calculated area now of the figure. So once you have the area here, all the 5 areas or more, no, then you need to get their total. No? Instead of the summation A, I use A sub t. No? And A sub t is simply, no, total area. No? So our formula eventually, no, will now, no, make use of this denominator 80. No? So instead of the summation symbol I used earlier, no, in our discussion, we have here, no, A sub t. Now we indicate it by A sub n because you could have n different figures there. No? So if in our example we have only 5, then n there would be 5, no, of these pairs. No? So this is how we get the theoretical value of our x and y, and we can eventually compare that, no, with our experimental value. No? So that's how we conduct the activity. But of course, your experiment, no, or your template, no, is attached, and you can see that there's your observation there, no, your discussion, your analysis, no, conclusion, and even your computational part, no, and the table that you have to fill up. No? So again, now complete your lab experiments, and again, you are given 10 days for this activity.